So now let's take a look at the NIEM technical framework, which will act as a base for everything else we look at. The NIEM uses XML schema to define its data components, so everything is defined in terms of XML schema. It's important to know, though, that the NIEM is not conceptually bound to XML schema. You could convert the concepts to a different technology, to some sort of ontology, to RDF. So you don't have to have this be as XML schema. Well, when I say you don't have to have, you do have to have it as XML schema in order to be conformant. What I mean is that the NIEM as a whole could be converted to another technology other than XML schema. So the NIEM uses XML schema, and you'll need to know XML schema to meaningfully use the NIEM, but the NIEM itself is not conceptually bound to XML schema. That said, XML schema is what we use. Now, the NIEM itself is built out of reference schemas. There's a number of different reference schemas, and they're organized into abstraction layers. The higher layers extend and use the lower ones, and the lower ones act as bases. The lower ones never, ever use things from a higher layer. It just goes one way. So you've got base layers and then other layers built on top of that. That allows you to make changes at the fringes of the NIEM without needing to make changes at the base. So remember, abstraction layers, higher layers extend and use the lower ones, but not in the reverse order. And we're going to look at that in diagram form. So here's a view of the reference schema abstraction layers. And as you can see, there are three main layers we're dealing with. At the bottom as a base is a support layer, and it contains reference schemas for proxy structures and app info. Now, what does that mean? Well, we're going to cover that in a little bit. Just so you know right now, those are support schemas upon which everything else is built. Think of it as the infrastructure for the NIEM, the nuts and bolts that work behind the scenes to hold everything together. Just above it is NIEM core. And that's kind of the core of the NIEM. That's where all the really, really common generic elements and types live. So if you want a plain old generic person or a plain old generic organization, those things are in NIEM core. They're very, very common things that everybody uses. They're there in a generic form, and basically everybody can use them, but they're nice and generic. Then the layer above that are the separate domains. And right now you see 10 different domains. At the time I made this slide, there were 10 domains. There may be more when you're watching this. I have no way of knowing. There will be more in the future. How quickly more are added is anybody's guess. Run through them real quick. Justice, infrastructure protection, screening, international trade, intelligence, maritime, CBRN, immigration, emergency management, and my personal favorite, Children, Youth, and Family Services, abbreviated as CYFS, and that's pronounced CYFS, because I say so. It's pronounced CYFS. The Children, Youth, and Family Services is actually the domain I personally work with a lot lately, and that will be kind of the focus of the rest of these materials. If you've come from a different domain, from a different community, these materials will still be, I hope, extraordinarily useful to you. But the examples are going to be Children, Youth, and Family Services oriented examples. Now, the nice thing about that is that everybody's kind of familiar with kids. Even if you don't have kids like me, you're still familiar with kids. In fact, gee, I used to be one. So hopefully the examples will still ring true to you and be something that you find somewhat interesting. But just so you know right now, Children, Youth, and Family Services, that domain is the focus of our attention for the materials, although they'll be applicable technically to any of the domains listed here. So those are the three layers: support, NIEM core, and the domains themselves. Now let's take a look at how they integrate together. Now I mentioned a couple slides back that the upper layers draw upon, use, and extend from the lower layers, but the lower layers don't do that in the opposite direction. So here's our first example of that. NIEM core draws upon the support areas. So NIEM core uses proxy, uses structures, uses app info in order to build its own elements and types. It draws upon the support layer, but the support layer does not draw upon NIEM core. What that lets you do is lets you update NIEM core without having to update the layer below, without having to update the nuts and bolts that hold things together. Here we see another example of a higher layer drawing from a lower layer. We'll look at just the CYFS domain, but this is true for any of the domains in this layer. The domains draw upon the support layer, so they utilize proxy structures and app info as well. But again, the support structure stuff does not draw upon the CYFS domain. It's a one-way flow. Children, Youth, and Family Services utilize that support layer below it. The support layer does not utilize the domain itself. The domain layer can also draw upon NIEM core. NIEM core is a lower layer, and so it's perfectly fine for the domain to draw from NIEM core, to use things in NIEM core, and to extend things in NIEM core for its own use. Again, the reverse is not true. NIEM core does not draw from the CIFS domain, nor from any of the domains. It doesn't draw from anything in that layer. Again, the advantage to this is that we can update the Children, Youth, and Family Services domain, or indeed any of the domains, without changing anything in NIEM core, because NIEM core won't use anything from those domains. So we can update those domains independently from NIEM core. Domains can also draw upon other domains. So in this example, the Children, Youth, and Family Services domain could draw upon things in the Justice domain, and indeed it does. So there are objects in the Justice domain that the CIFS domain either uses as is or extends to make special versions for itself. And vice versa can also be true, although it isn't in this particular case, it can be. Domains can draw from each other. Now that does throw a little bit of a wrench into the updating process, in that if I update a domain, other domains that depend upon things in my domain might be affected by those changes. So there is a harmonization process that occurs every time we want to do a sort of a mass update of all the domains, and that results in a minor release of the NIEM. Let's look at each one of these layers in a little more detail. The bottom layer, the support layer, has three different reference schemas that provide infrastructure for the rest of the NIEM to build upon. There's the proxy schema, and that adds infrastructure pieces to base XML schema data types. In other words, XML schema has things like integers and strings and various other kinds of numbers. And the proxy schema basically adds NIEM infrastructure pieces to those basic schema data types. So instead of having just a plain old integer, you have an integer with NIEM infrastructure bolted onto it so that it can work with the rest of the stuff. The structure schema provides NIEM base types and a mechanism for meaningfully linking those objects. In other words, it provides some referencing and some associations that lets you hook different things together. We're going to look at this in detail later on, but it's a very powerful mechanism that helps the NIEM replicate real-world relationships very flexibly. And then finally, there's the app info schema that provides a mechanism for adding additional information to things for tools and other human beings to, not to imply tools are human beings, but for tools and human beings to understand and get additional information. For example, the conformance indicator is part of app info, and it kind of ends up being kind of a catch-all for extra stuff we want to add to tell you about the things within the NIEM. I already gave you a decent amount of detail about the NIEM core layer. It's commonly used generic objects, persons, associations, generic activities, things like that. It utilizes things from the layer below, the support layer, and the domain layer uses and extends objects from it, but it itself does not use objects from the domain layer, again allowing us to update domains without having any effect on NIEM core itself, so we don't have to update NIEM core each time we update a domain. And then finally we have the domain layer, multiple domains, 10 of them, multiple schemas, 10 of those, one schema per domain. So the elements and types for each domain are encapsulated within a single schema for each individual domain. Each contains objects that are specific to that domain. That's what that domain is about, things about that domain, and they're all in that particular schema. As we talked about in the diagram, domains can use objects from the support layer, and in fact they depend on them. That provides the infrastructure. Domains also use and extend objects from NIEM core, but again the reverse is not true. NIEM core does not draw from the domains. And then domains can draw from each other with the caveat of if you draw from another domain, if that other domain updates, that's going to have an effect, a potential effect on your domain as well. Now there's one other piece to this abstraction layer puzzle, and those would be external standards. Now sometimes external standards are whole bunches of elements and types, and there's a whole mechanism for bringing those in. But other times all we're talking about are code lists that have an authoritative source somewhere. Some common ones you'll see in the diagram are the FBI, FIPS, ISO, there are others. So these are standards bodies. I know it's strange to think of the FBI as a standards body, but they really are in terms of codes for different kind of things that the FBI is concerned about. So they're an authoritative source for a lot of code tables. And these code tables are utilized within the NIEM as well, because code tables are great because they constrain values and thus increase your reliability and your accuracy. As with everything else, these external code tables draw from the support layer, because that provides the infrastructure for all of this. So they draw from support, and then domains draw from those standards. So domains can use the various code tables within their own elements. So Children, Youth, and Family Services utilizes some code tables for which FIPS is the authoritative source. For external standards that are more than just code tables, things get a little complex. There are multiple schemas, one per external standard. We wrap objects from those standards in NIEM-conformant objects called adapters. So basically, you have an external standard that doesn't follow NIEM rules, but you need to use that external standard. You take objects from that standard and you wrap them in adapters so that the adapter, the wrapper, is NIEM-conformant and the non-NIEM-conformant stuff is wrapped safely up inside of it. The bottom line is it lets you use non-NIEM conformant standards inside and along with other NIEM stuff, and that's a nice thing to be able to do. The downside is that that's kind of advanced stuff, and it's really beyond the scope of this material. If you find that you do need to integrate external standards within your NIEM conformant work, you're going to want to seek out basically a hardcore NIEM expert who has some expertise in using external standards, but it's going to be beyond the scope of these training materials.